Lesson number 9, Heat. What is the difference you feel if you touch a hot cup of tea and an ice cube? You will say that the hot cup of tea is hot and the ice cube is cold. So how did one object was hot and the other was cold? It is because of the measurement of the temperature of this object. So what is its temperature? Temperature can be defined as a measure of the average kinetic energy of the particles of an object. The kinetic energy of an object is gained due to the movements of the particles of an object. If the particles in an object are moving slowly, the kinetic energy is going to be low, thus the temperature is low in that object. While on the other hand, if the particles are moving very rapidly, the kinetic energy is high, so the temperature of that object is high. How do we measure temperature? Liquid thermometers and digital thermometers are used for this purpose. In liquid thermometers, the expansion property of the liquid is used. When the temperature increases, the liquid will expand and rise up through the capillary tube. Then, from the scale, we can read the temperature. There are two types of liquid thermometers, the glass mercury thermometer and the glass alcohol thermometer. In the glass mercury thermometer, mercury is used as a liquid. Due to the large and uniform expansion property of mercury, it's widely been used. And also due to its color, the scale can be easily read. But as mercury is toxic, its use is being declined. Nowadays, instead of the mercury thermometer, the digital thermometer is mostly used. In alcohol thermometers, alcohols are used as a liquid. Usually, ethanol is used as the alcohol. As the melting point of ethanol is minus 115 degrees centigrade, it's suitable for measuring low temperatures much below 0 centigrades. Centigrade, Fahrenheit, and Kelvin are the three common scales used to measure temperature. When forming a temperature scale, definite temperatures are used which are known as fixed points. Both in Celsius and Fahrenheit, melting points of ice and boiling point of water are used as fixed points. In Celsius scales, melting points of ice is considered as 0 degrees centigrade, while the boiling point of water is considered as 100 degrees centigrade. Thus, its scale is divided into 100 parts. In Fahrenheit scale, melting point is considered as 32 Fahrenheit and boiling point of water is considered as 212 Fahrenheit. Thus, its scale is divided into 180 divisions. In the Kelvin scale, the absolute zero is being used. So what is this absolute zero? Absolute zero is the point at which the motion of particles of matter has completely stopped. So in the Kelvin scale, the absolute zero is known as 0K. And if we compare this with the Celsius, it's going to be equal to minus 273 degrees centigrades. And also keep in mind the international unit for measuring temperature is Kelvin. If you look at the relation between Celsius and Kelvin, the absolute zero in Kelvin is equal to 0K and in centigrade it's minus 273 centigrades. The freezing point of water in Kelvin it's going to be 273 Kelvin where it's going to be 0 centigrades in the centigrade scale. The boiling point of water is going to be 100 degrees centigrades, while in the Kelvin it's going to be 373 Kelvin. If you want to convert Celsius to Kelvin, you have to add 273.15 to the Celsius value. And if you want to convert Kelvin to Celsius, you have to subtract 273.15 from the Kelvin value. So here you can see that the Kelvin value is going to be always large than the Celsius value. What is heat? Heat can be defined as the flow of thermal energy from one object to another where there is a temperature difference. And also, heat always flows from warmer to cooler objects. If you take an example, when we place a hot tea cup in our hand, the cup is going to have a higher temperature than the hand, so the heat is going to be transformed from the cup to the hand. So we are going to feel a little bit hot to our hand. On the other hand, if we keep an ice cube on our hand, what's going to happen in there? The temperature of the hand is going to be higher when we compare to the ice cube. So the heat is going to be flown from our hand to the ice cube. So eventually we are going to feel that our arm is going to be a little bit cool. Always heat transfer from warmer object to a cooler object, but after few minutes both are going to reach a common temperature. This state is known as the thermal equilibrium of the object. At this state, no heat is going to be transferred between the objects. If we give the same amount of heat to the same amount of water and coconut oil, and if we check their temperature, will the temperatures are going to rise equally? No, it's not. Their temperature rise is going to be different. So what is the reason for this? Because all the substances, the storing capacity of the energy is going to be different. So this can be known as the heat capacity. If you take the definition of the heat capacity, it can be defined as the amount of energy to change the temperature of a body by unit temperature. That means different substances are going to have different heat capacities. The international unit for measuring heat capacity is joules per Kelvin, but heat capacity also can be expressed in joules per degree Celsius. If we measure the heat capacity of 1 kilogram of a substance, that is known as the specific heat capacity. In other words, if we define the specific heat capacity, it can be defined as the amount of thermal energy required to produce unit temperature rise in unit mass of that material. The units for the specific heat capacity is going to be joules per kilograms per Kelvin. In order to find the quantity of heat flow in an object, we can use the following equation. That's the Q. Q is the quantity of heat equals to mc theta. Here the m is the mass of that object, c is the specific heat capacity of that object, and theta is the temperature change.